Hi, good afternoon, everybody. Thanks for coming. And in today's session, I'm pretty much doing all the coding, so I only have 3 slides. So this is one of the slides. So it's, I will create cloud-native applications using MicroProfile and Open Liberty, and also deploy to Kubernetes. So it's I use the Docker desktop. So it's, and then you see how can easily configure them and get them running and etc. I'm Emily Jiang from IBM. I'm a Java champion. I'm also the cloud native architect and also the chief advocate for Liberty. So before I go ahead, can we do a show of hands? How many of you know MicroProfile already? That's great. How many of you know Liberty already? Okay, good. A few hands. So it's this session is kind of has a longer version, which is this book. Is practical cloud native application development with MicroProfile. So we are going to give away quite a few books. So please go to the IBM booth at 5 today. There's also for drink and snack, and to get a signed copy. This is my second slide. With that, I think the third slide is just a thank you. So I will directly stop this. So I will use my IDE here. So basically, I will use VS Code. So how many of you are using VS Code? Anybody? Okay. IntelliJ? Eclipse? Wow, it looks like a equal. Anyway, use IntelliJ. So it's in the like a MicroProfile. There's a MicroProfile starter. So basically, it has a plugin for VS Code. You can install it. It's called a MicroProfile is extension pack, and the same extension pack available to VS Code. So I just I have that installed. That starter MicroProfile, and then I will do a CM4G. It's an artifact ID. I use MicroProfile 5, which is the latest MicroProfile release. So MicroProfile 6 will come in soon. I use Liberty. Hopefully, there's more runtime server will be added to this list. And I use Java 11. And very soon, we will want to add Java 17. Who are using Java 17 in production? Okay, 11? 11? Good. 8? Okay, I feel like 11 is more. However, tell you true, I am using Java 19 for this demo. But my app is running on 11. I use Maven. Who are using Maven at the moment? Maven? Gradle? Okay, so it looks like Maven is the majority. So I only want to create 2 microservices. Is service A calling into service B. And also I want to get the health endpoint. So with that, I just want to show you is one is not secured, the other one is secured. So I choose GWT. And then I generate that. I go to the demo folder. Oh. So it's with that actually is all the kind of the project being generated. You can see the service A and also with the service B. So with also we have the in the kind of the VS Code and also we have a Liberty dashboard. So I can start actually service A. Also I can start service B. And this is start in the dev mode. Where is the starting? and I explained to you like a service B. So basically, is just as a RESTful services. It has two endpoints. One is the service controller. So you can see it's just do something, process directly echo out the parameter pass prom. The other endpoint is protected. So it's basically is kind of this is give you rules allowed. So it's and then it's only allow if you belong to the kind of the protected group, and you can access this this endpoint. Otherwise, you are not allowed to access it. And then is for service A. So service A directly is trying to call into service B. So it's in here. So it's how can service A call into service B? So it does, it uses MicroProfile REST client. If you know Spring, how many of you are using Spring at the moment? Spring? Only one. Or if you use Spring, it's pretty much is like a thin client. So here is basically you create the service B's interface, just do something, pass param, and you annotated this interface with register REST client. And then the implementation will create an instance for you, and then you can directly do a add inject REST client, and then you can call it. And you might think, how can service A know where service B is? So that's the beauty of the config. So it's you can configure use the fully qualified class name. So the service is com example cm4j client dot service. And then /mp_res/URL, you put like service B's URL there. And then is when you call like a service or do something, it will go to the service B endpoint and perform the request. And then you will get a response back. So that's kind of with that, like both service A and service B are up. So it's on the 9080. If I do the 9080, so you can see here, like this is REST client. You can directly call it. You can process parameter value. You might think, how do you know it's like service B? Let's go back to proof. So basically, is if I just directly change service B here, if I say EclipseCon 2022. I save that one. So it will automatically pick up the new change. And let's go back. So you can see the change is kind of is a real call into service B. So now I want to like change like service A a little bit. So basically, I want to just saying hello conference. However, I don't like just say here. I can say hello. Maybe I say conf. And then I don't really want to hard code the conf. So I can use the config to directly inject the property. So I can do the at inject at config property. So I will say name equals, for example, conference. And then this is a string conf. So I can save this one. And then is you will get an error message straight away. That makes sense because I haven't defined anywhere about this conference. Also, the IDE will help you out. So why it help out is because we have also language server like a protocol enabled for MicroProfile. So it's also once you install VS Code MicroProfile extension pack in VS Code, you get the whole support. So let me define the conference property. You can define the conference property in MicroProfile dash config.properties or environment variable system properties. See, as you can see here, once you like a conference, MicroProfile dash properties, so I can see EclipseCon. So I can save that. So what is called a conference? I see. Hang on. How come? Hello. Conf. I think I put in a different place, and the name equals conference string conf. I can save this one. So early on, I don't want to update this one. This is service B. I don't want to change service B. Save that one. So this will be happy, and this one will be happy. So you can see here. Here, if I change the name, you can see it says not defined, because it's I defined in here is a conference. So if you have a typo, it also can pick it up. So let me save that one. Let's go back here. You can see here, hello EclipseCon. So here is I really need a space. So this is beauty of the like live loading mode. So Liberty demo mode. So you can just see if something not working, not quite happy, and you can change and then save it. You can see the changes straight away. So you can see here is the kind of the. Let's go back. Yeah, you can see the. Yeah, it's still not quite, and then I will be able to keep changing it. So this is the kind of the config. So the other thing that I want to demonstrate to you is how can create resilient microservices. If service A call into service B, if service B is not functioning, actually it's if the client directly faces service A, actually it's the service A's responsibility to always return a good response to the client. No matter you have any other disaster in the backend, but it's your responsibility. So let's mimic that scenario. Like in service B, let me make it really kind of sometimes not working. With that, let me directly copy something from here. So basically, sometimes it's really not working. If I change this one, let me just define a static int count equals 0. As you can see here, is sometimes really slow, and sometimes is through exception. Let me save this one, and let's go back here. You can see here is keep on really slow and then come back. We can fix that. So we can fix it directly if we use the MicroProfile fault tolerance. So MicroProfile fault tolerance is create a way for you to fail fast. It offers a few annotations like a bulkhead, circuit breaker, retry, timeout, and also fallback. So in this, because it's really slow, I really want timeout. So I can say timeout. I'm this is time critical. I can say, okay, within 100 milliseconds, if you do not want, if you can't return back, I want to get an error. I don't want to wait it. When you use a timeout, it's always best practice to use make it asynchronous. So it's with asynchronous, you need to return either completion stage or future. So it's best practice always return a completion stage. So it's which means you can use better APIs, and also threading management is a lot better. With that, completable future, you can do a completable future, and you can do a completion stage. And then you can go in here. Let me save this one. So hopefully, let's go back here, and hopefully it won't see, it's sometimes it's still not working, right? But you don't have the slowness anymore, right? It always come back. It's because it's timed out. So it's to fix it, it's very simple. It's sometimes working, sometimes it doesn't. So it's you can easily just do add retry. Retry is always the first idea. So you know the retry, you can specify max retry, delay unit, and etc. Jitter, and how much time you want to wait between the retries. So you save this one. Now you go back again. You can see 14 directly jump to 16 because there is something not working. Is directly did a retry. It's always working now, right? It's not slow, nothing else. So if you want to deploy your code to Kubernetes, is always best practice for any critical application. You should always provide a fallback. So you can just say fallback, and one of the easy things is you specify fallback method. You can say my fallback, and then you specify this method. For that method, it needs to be exactly same signature as this one, but with the method name my fallback. So obviously, my fallback, you don't want to do invoke the same thing. You could invoke the alternative like a method and etc. Oh, this is my fallback. At least you don't throw errors back to your client. You just say, we do that. But in this local environment, you won't be able to tell it because it always work. So it's only in the cube, and sometimes the backend is nowhere to be found. You will automatically get into this map fallback. So this is another thing. So the next thing I want to show is actually you automatically get some metrics already with the MicroProfile. So if I go back here, if I say localhost, because it has an endpoint 9080 and the metrics, you can see all of these metrics. Let me make it bigger. You can see load class and also JVM time and a vendor metrics and etc. And then even better, you can add your own metrics. So in here, I can just say maybe I agree to simply timed. That's the metrics. From MicroProfile metrics, I can say name, make it EclipseCon. I save this one. Now I go back here and I invoke this again. Invoke a couple of times. Now you can see the even more metrics. Basically, is towards the end you can see the EclipseCon. See EclipseCon, the name Eclipse counter gauge and etc. And there's a lot metrics, and also you can see the fault tolerance metrics as well. So with the integration for tolerance with the metrics, and also it provide some fault tolerant metrics for you, like how many time being retried, and also the method execution. So it's also the how many time being timed out. So a lot goodies for you. The other thing is with MicroProfile, I haven't done any changes whatsoever. You automatically got OpenAPI. So any of you know Swagger? Swagger? Okay, a few of you. If you know Swagger, you will know this OpenAPI. Also in Open Liberty, we have this UI. You just say OpenAPI/UI. In MicroProfile, if you it's in the spec, it directly give you this output, like all these endpoint is based on OpenAPI 303. So if you do UI, and you can directly even invoke the operation. You just say, try it out, say hello, execute, and then, yeah, it will be in here. And then here you get a description, like 200 means, and etc. You can even add more description by using a MicroProfile OpenAPI annotations. So let me directly demonstrate to you. So here, if I add this one, let me quickly go back to organize the import. Let me save that one. So let's go back here, and then you can see. You can see the 200, basically 200,404. So with that, you can see what I have been added. So here you can see API responses. It tell you 404 means what, and also the content type. And 200 means what, and then also the content type. So it's, let's go back here. Oh, let's go back here. So it's so get the backend. If I say try it out, you say hello again, execute. See, you can see the message straight away. So it's like a process parameter value. Yeah, hello again. So it's, this is really handy and very simple and straightforward. So it's, the other thing is I want to quickly show you is not only like this is I have demonstrated like fault tolerance config, also the OpenAPI metrics and etc. And also there's a MicroProfile health, so that if you upload this application to Kube, and then you need to provide liveness, readiness and startup check. So it's all you need to do is create 3 classes annotated with the liveness. So basically, the most things you will put in here is whether you have a RAM or not. So got a sufficient memory or not. That's the one, the kind of the common practice. And for readiness check, normally in this, you implement this method, is normally you will say whether it's kind of you can reach your backend or the database or not. So for the startup, so basically this is to tell you whether your application is started. So whether you can in any state can be serve request or to be checked whether live or not. So it's in Kubernetes, it will check a startup first before it check readiness or liveness. So it's with like a MicroProfile health, it has at least three endpoints: /health/ready/health/live and /health/started. So it's let me see. So it's localhost. So let's you can see health and live. So you can see all in the JSON format, and also the ready again in JSON format, and then started. So this is all the, you can just add more information here and add more data. So this is this is the kind of the show you how can you get started with your cloud native applications. The next thing I want to demonstrate is I haven't done anything here. However, if I have Jaeger in running in the background. If you know, so you can see the CN4J, and you can get all the trees straight away. So it's all the trees spans. So it's basically with the MicroProfile open tracing, all the trace ID is properly propagated up to the backend. So all the spans is correlated. So you have only one trace and contain multiple spans. So that's the kind of the for the quick run through some more aspect of the MicroProfile features. The other thing I mentioned, in this service B, is the one backend is pretty much protected. So the rules allowed is protected. So it's in service A, the client directly call into that backend. When they're trying to call into the backend, I need to pass in the token. So it's how did it do it? Basically, in this call, it uses the Jakarta RESTful the client. So client build a new client, and when it do the request, also is passing in the bearer header, so the JWT token. And how to get a hold of JWT token? You could get a hold. You can use the API to create a JWT token. You use so here you use Vertex. So we use the Vertex API. Also, Open Liberty provide an API to allow you to create a token. However, in production, you don't use this API to directly create a token. You would use Kcloak, use Okta to create this JWT token. So in MicroProfile, all it does is basically in a standard JWT token, it added two more claims. One is the UPN, so here. The other one is the groups. So this is very key. So this UPN means the user, who are you? The groups means which group do you belong to. You can see here this user belong to user or unprotected. Because the backend said, okay, if you are protected, you can access this backend. So in this case, so if I go back to the backend here, if I call in here, so I can get this response. And let me show you the code. So the code is basically is service in the service B. So in the service B, it says protected resources. I can just change is service B, for example. You know it's a real service B. And let's go back here. So you know this is it did return successfully. And if I change here, I will say only super allowed to access me. So now I go back to try to invoke. I won't be able to get any response back. It's because I don't belong to a super. So let me go back to change it back. Protected. So the other thing I want to show you, actually, you can even get a hold of the token. You can inject a token even. You can use a JSON web token. You can just do a JSON web token. And in here, you just say token. Say token gets a row token. So let's save that. Let's go back here to just invoke. As you can see, it's successfully and also export display this token. This is a JWT token, but it's a kind of almost like a blob here. And however, because it's encoded, if you know JWT, actually, if you go to jwt.io, the internet is quite slow here. And then is you can like post here, and you can see it's automatically decoded. You can see here the group is user protected, the UPN, the JSA, and then type is JWT. This is RS256. It's not encrypted, so it's just a sign, not encrypted. It can also encrypted. You can use specify encrypt algorithm as well. There's many algorithms for you to use. So this is quick run through of the MicroProfile specific MicroProfile features with cloud native application development, so that you can easily use the application directly, use the APIs to create a really well-performed kind of the cloud native applications. So the next thing, what I want to show is basically, up to now, you are pretty happy with your application, basically service A and service B. And your next stage, you want to Dockerize it. Yeah, you can either use Docker or Podman to create a container, and then you can deploy to Kubernetes. So it's with that, we can just get a Docker file. So first, let me stop this one. Also stop this one. So I can do service A. Here is go to service B. So I can do a Maven verify to service B. And also I just build a wall. And then I can just create the Docker image. So what is it doing? The building is a package. So it's I have another one. Just let me directly copy into this one first, and then explain to you how it works. Let me copy the few files. So I just need to copy the Docker file to service B, and also the Docker file to service A. So it's so now I have a Docker file. So this is a Docker file. So Scene4j and Bootstrap property, and also it uses the Docker file for Java 11 OpenG9. We use OpenG9, and then I can directly do a Docker build. Let me directly copy the Docker build. So build this one is service B, and do a Docker build. It might take a while. However, like with this very slow Wi-Fi. However, I can just so it's in the other application here. Let me explain you the so in prepare this like a demo. So it's I prepared kind of the other application. So it's as you can see here, it's basically you do the Docker like a base image, and then you change your owner, and then you copy the config, copy the bootstrap property, copy the wall, and then this is the optimization config.sh. So it's basically you have two Docker image created. So then after you have built your Docker image, so the next thing is to do the deployment, to your local environment. So it looks like this one is already done. So it's look at this is the image. You have a wall, and I can create another one, and also I can copy the deployment file and show you what a deployment file looks like. So it's after that, so after that, so basically it's kind of, this is the deployment file. So basically it's kind of you do a deployment, also you create the service, and also you can overwrite the backend, like a backend. So earlier you say localhost 9081, but once you deploy to Docker, to the like a cloud Kubernetes is no longer localhost. So this become a CM4J. The other thing you remember slash in MicroProfile config is automatically can transform the like a slash into underscore, because slash is not valid character for the environment. And also you can see here Lebanese prop, so you can plug in the health endpoint, Lebanese readiness prop health endpoint. So the two deployment, and also the two service. So and then service A, you have the node port, and service B, you have the cluster IP, because the service B doesn't need to be out-facing, and service A does. So it's let me see. Yeah. So it's it's a map to the localhost. Let me directly say map to localhost 380. Okay, 30. So it's you can see here, REST client. So if you're not working, and fallback, if you're working, is working like this. So in the you can do kube control get services. So you will be able to see it's automatically map 9080 to 380. And the beauty of the config is you can reconfigure this is backend, and then also reconfigure the conference as well. So you can see EclipseCon, and you just do an update, and it will pick up the changes straight away without re-upload your application. So with that, I think I'm a bit overrun a bit. Sorry about that. And yeah, I will be at the IBM booth afterwards. If you have any questions, come over to find me. And yeah, thanks for coming.